Hi everyone. So I'm just going to take you through what's called a transformation question with the first order differential equations. So here's an example that we're going to look at. So here we've got the differential equation dy dx equals x squared plus 3y squared over 2xy, and we've been asked to show this substitution y equals xz transforms the differential equation into this. Why do we want to do that? Just to make it an easier equation to solve. Okay, so if you look at that, that's actually rather a difficult differential equation to solve as it is. So sometimes a substitution helps us to transform one equation into another one that's slightly easier for us to go ahead and solve. Okay, and then after that we're going to find the general solution of this equation, which will then help us to find the general solution of that. So that's what we're going to do in this video. Okay, so first step is using our substitution y equals xz. Now we've got to find what dy dx is. Okay, so use the product rule for that. So you've got a product of two terms, so xz, so v du dx plus u dv dx. So using the product rule, so you've got here, so v du dx would be z times the derivative of x, which is 1, so z times 1, which is that, and then plus u dv dx, so x multiplied by the derivative of z. Now z is not a constant value, it's a variable in terms of x, so you need to do that implicitly. So we differentiate z with respect to x, you get dz dx. That's something you just got to get used to with these transformation questions. Okay, so x dz dx there. Next thing what we're going to do is we're going to substitute into the original equation. So just to remind you what that is. So we had dy dx equals that. Substitute this in. What I would do is, because you've got dy dx, I'll just rewrite that in place of this there. Okay, and that's what I've done in the next line. So here dy dx is z plus x dz dx. And then replace y with xz. Okay, so you've got x squared there plus 3 and then y squared, so that's going to be 3x squared z squared all over 2xy, and so you've got y is xz, so 2x squared z. Okay, so we've got that. And then next step, what we want to do is we want to get down to our result, which was this here. Okay, that's our result that we wanted, just as a reminder. Okay. So next step is we're going to put the z here onto that side. So all of this subtract z, combine this as a fraction, a single fraction. Okay. You get this line here. So the denominator 2x squared z. So include that in one single fraction, that would be 2x squared z squared. Notice these two bits will simplify. So 3 of that subtract 2 of that just gives you x squared z squared. So your next line here, and then you can just divide top and bottom by x squared to get 2z on the bottom, and then 1 plus z squared on the top. And that's what was required. That was our original question. Right, so it's got this is equal to that. Okay, that's done. So that's the transformation of the differential equation. Now we've got to go ahead and solve it. So solving this differential equation, you can separate the variables in this case. Okay, so a lot of the time with first order differential equations at this level, you need an integrating factor, but sometimes just hold on and check. You can actually separate the variables. What I mean by that is you can keep the dz there and put this entire term to the left hand side. You can move the dx into that side and put the x into that side, and then we're done. All the z's, dz's on one side, all the x's, dx's on the other side. And it looks like this. So move that over there, move that over there. So 2z over 1 plus z squared dz is equal to, put that over there, put the dx over there, 1 over x dx. And we'll just go ahead and integrate each side separately. So the left hand side, that's of a standard form with a natural logarithm. So check that when you've got a fraction, differentiate the denominator. If you get the numerator perfectly, it will be the natural log of the denominator. So 1 plus z squared, natural log 1 plus z squared. And as you know, the right hand side is just going to be natural log of x. And don't forget the constant. Normally we write a constant as plus c, but what I'm suggesting is it's easier when everything else is in terms of natural logs to write it as natural log k. So rather than plus c, write natural log k. The reason for that is you can combine the natural logs using the logarithm rules. You can combine the right hand side as the natural log of kx. And then you've got natural log this equals natural log that. You can then just undo the natural logs. So you've just got the 1 plus z squared in brackets is equal to kx, and it's much simpler. Next, remember what we're doing is we're trying to solve the original differential equation, and to do that we need to use that substitution, which is y equals xz. So rearranging that, of course, you must have z is equal to y over x. So here you can have 1 plus y squared over x squared is equal to kx. Now sometimes the letter a is preferred in mathematics, the letter capital A is preferred rather than k, so I'll just put that in there because that's how most solutions seem to be given for these types of questions. And if you want to write y squared as a subject, just subtract 1 and then multiply by x squared. So y squared equals x squared, ax minus 1 as the general solution. And that's it. Right, hoping that made sense to you. Thank you very much for watching. Have a good day.